Lesson 35 is about factoring the greatest common factor and canceling. And the first question that we have says factor the greatest common factor, or GCF, of 2ax plus ac. So if I write that out here, 2ax plus 2ac, what we're doing when we're factoring the greatest common factor is doing the distributive property in reverse. We know how to find the greatest common factor. The greatest common factor of 2 and 2 is 2. The greatest common factor of A and A is A. There is no greatest common factor between X and C. So what we're going to do when we factor the greatest common factor is multiply this against something in parentheses, opposite of distributive property. So 2A times what is equal to 2ax? We must have to multiply that by x. And then plus in the middle, because we've got plus here. And then 2a times what is going to give us 2ac? We're going to have to multiply it by c in order to get to 2ac. Watch how this works in reverse. So if we now had this problem, 2a times x plus c, and you were asked to expand using the distributive property, well, what you would do is you would multiply 2a times x, and you'd get 2ax. Then you'd multiply 2a times c. You're going to add that to what we originally have. 2a times c is 2ac. We found our answer because the original problem and our check work. So the answer for this question, when we factor the greatest common factor, we get 2a times the sum of x and c, right here in blue. We're all done with this question. Let's move on to our next problem. Okay, let's factor the greatest common factor. We're given this expression. So let's figure out how many common factors we have of a. Well, we've got a to the third, a squared, and a to the fourth. We must have a squared in common between all of them. X squared, x, and x to the third. We must have an x in common between all of them. Then we have an m squared, an m to the third, and an m squared. We must have an m squared in common between all of them. Now to factor the greatest common factor, we're going to multiply. In order to get to a to the third power, we need to multiply a squared times another a. In order to get to x squared from x, we need to multiply by another x. M squared, we're already there. We're going to add. In order to get from a squared to a squared, we're already there. X to x, we're already there. And m squared to m to the third, we need to multiply by another m. Now we're going to subtract. To get from a squared to a to the fourth, we're going to multiply by a squared. To get from x to the third, we're going to multiply by x squared. And then to get from m squared to m squared, we're already there. Close off our parentheses, we've got our answer. This is how we factor the greatest common factor. Let's look at our next example. We have one more. We want to factor the greatest common factor of this expression. So, 3 and 1. Well, the greatest common factor of 3 and 1 is 1. We don't have to write that. M to the third and m squared. Must be m squared is the greatest common factor. X, nothing, so there's no greatest common factor there. And y squared and y. We have a y as our greatest common factor between the y's in our expression. Then we're going to multiply. To get from m squared y to this, we need to multiply by 3. We need to multiply by another m. We need to multiply by an x. And we need to multiply by another y. Then we're going to add, because that's what the expression tells us to do. Then we have m squared y. We have m squared y. We're already there. So we're going to add 1 to this, because if we multiply m squared y times 1, we get m squared y. And we've got our final answer. This is exactly how we factor the greatest common factor of any given expression. Now the second part of this lesson is all about simplifying and canceling. And when we look at this expression, we have 4 times a minus 3 over 4. Well, in this problem, what we have is 4 times all this. We know the opposite of multiplication, or the inverse of multiplication, is division. So what we can do is we can say 4 divided by 4. That's 1 over 1. and we get an answer of a minus 3. We've got our final answer here. Now the next problem, 3p plus 3 over 3, it's a little bit tricky because when we look at it, it looks like the 3's could cancel. But we have to do everything in the numerator first because there's addition within these terms. Notice how our factor in the first problem was on the outside of our parentheses. So what we have to do in this second problem is get a factor on the outside of our parentheses. So we're going to factor. What's the greatest common factor of 3 and 3? That's 3. So we're going to have 3 times, to get from 3 to 3p, we multiply by p. And to get from 3 to 3, we multiply by 1. So it tells us to add here, so we're going to add 1. This is all over 3. Now we have our factor on the outside. We can cancel, because 3 divided by 3 is 1 over 1. So we get an answer of p plus 1. We fully simplified this, and we didn't even have to multiply, because we canceled out beforehand. We've got one more example today. Let's go ahead and simplify this expression. Now you might be tempted to try to simplify the 5 and the 5 and the x and the x, but you can't because this all needs to be done first. In order to simplify, we need to get a factor on the outside of our parentheses. So let's find the greatest common factor of our numerator. Well, the greatest common factor of 5 and 25 must be 5. They both have a 5 in common. The greatest common factor of x and x squared is x. Then we're going to make our parenthesis. To get from 5x to 5x, we multiply by 1. We've got subtraction this time. Notice. To get from 5x to 25x squared, we're going to have to multiply 5x times 5x, because 5x times 5x is 25x squared. We've got our numerator. This is all over 5xy. Now we can go ahead and simplify. 5 divided by 5 is the same thing as 1 over 1. And x divided by x is going to be the same thing as 1 over 1. So we've simplified before we multiply. We can get our final answer now. Our final answer must be everything that's left. 1 minus 5x over the remaining y. And again, this was a y. We'll practice this more with our lesson practice on page 144. Make sure you've got your notes complete, and I'll see you during our next class.